mark. First mark. This is for the displayed formula of the organic product. This reaction can be on your mini assessment today. Pay careful attention. Rosalind, this mark is for you. You got the mark. All right, donuts. Woo, give a round of applause. Extra donuts? Extra donuts.
Okay, just fully believe it.
All right. Answer. How do we get it? So.
Will I finally be called?
I'm called.
Oh my God.
Before we answer, let me get your full attention. The idea here is we're adding HCN, right? You have to add across the double bond. If you remember the general reaction, the H always adds to the oxygen, and the CN always adds to the carbon. So it adds like this, H and CN. Now, would this give us the mark? We actually have to write out CHHH because they said display, right? COH, C triple bond N, and H.
Oh, the other.
You should write every bond in a displayed formula. Every bond. So this would be the correct answer. That we gave. Yes. Every bond.
Oh, that's good to know. That was wrong. Wow.
So displayed. Next question.
Please. Please. Oh no, please.
Next question.
It's right.
Cat. So first of all, do you have it? Let's
I
try.
don't know who I am. And I don't want to know.
It's correct. Correct. All right. Get that donut. That was the easy mark. But still, you could have gotten it wrong. People that got it wrong.
I said you say something that I don't.
Right. Nice. All right. The answer to this was as simple as addition. Like, if you wrote addition, you got the mark. If you wanted to specify, it would be nucleophilic addition, but it just asked for the main type. It said addition reaction. End of story. Yes.
What question is it that you could just put out one nucleophilic and it'll be?
They would have to say they're looking for the mechanism, or another keyword would be fully named. The mechanism associated. Then it's nucleophilic. But you have to add nucleophilic or electrophilic if they ask for the mechanism. But they didn't. They just asked type, major type. That's it. So finally, mechanism time for this slide.
Come on. No, it doesn't.
Hey, you got that mechanism?
Not the one I wanted.
No. All right. All right. And so,
You should know this, right?
what happened?
But
I'm ready.
but
So, real quick,
know this.
go over what it is. Because there was definitely a significant issue here. Although you are not going to be assessed on mechanism today, I would like you to encourage you to look at the class schedule. I gave you the date of which day you are going to be assessed on mechanisms. It's going to be Friday. So study all your mechanisms for Friday. What do we do? Page 3, C.
That's what it is right now.
What happened?
It's not always.
What's that?
He's asking what
Reaction. That we're done. All right. So first thing, let me get your attention. Dipoles. Carbon should be positive. Oxygen should be negative. Then you start by incorporating your CN minus. Where should the two electrons be that start the mechanism? You don't have to. The H will come in later. like this, and this. So then you end up with intermediate, CH3, CO
My pencil.
minus CN,
Same thing happens to
H.
me.
Then you incorporate the HCN. Because remember, there's always a CN minus catalyst. Here, you would grab the hydrogen, and this would fold over back to become CN minus. So you start end-end with a CN minus. And then, so your final product here is CH3. C, it's the same thing as before. This
Just like a
mechanism
chain
is
reaction.
always the same. And then plus CN minus. This is a catalyst because it's there at the beginning and it's there at the end. This is the same mechanism we did last week. Let me repeat again. On Friday, at the beginning of class, because we have a lab that day, so you can't do the mini assessment at the end of class. So at the beginning of class, on Friday, you're going to be given 2 random mechanisms out of the ones we've learned. I'll repeat this when we review on Wednesday. We're going to review on Wednesday, but the mechanism quiz is on what day again? Friday. It's going to be a mini assessment just like all the others, except it's just going to be 2 mechanisms instead of, you know, how we usually have 10 practice reactions. It's going to be 2 mechanisms. It's going to be at the beginning of class because you have a lab that day, and I promise you the lab, once we start it, it'll take to the end of class. It's a fun lab, by the way. It's on Friday. All right, so this question. I do see people with the right answer. I don't really see the work, but I'm going to go ahead and attempt it anyway.
Lucky number 5.
This is for, I'm just trying to get away donuts.
David.
Ernesto, let's see, you got the answer?
Look it up.
Bitch, you should keep rolling until someone gets right. If they get it wrong.
I'm sorry. All right, I'm going to go ahead and explain it.
Right.
All right, even if I don't know that you all know this one because this is one of the ones that I wanted to teach you something here, just in case. If you got the answer and you understood this, just pat yourself on the back. You got O2, right? It could be any number of 3 oxygen isotopes that's contributing to O2. So you could have O2 that is comprised of oxygen with a mass of 16 and another oxygen with a mass of 16. And the mass of this O2 would be 32. You could have a combination of oxygen with 16 and oxygen with 17. That would give you 33. You could have a combination of oxygen with 16 and oxygen with 18, and that would be 34. And before I move on, each of these masses are different from each other, so on a mass spectrum would give you a peak at a different number, right? Let's keep going. It's asking again, how many peaks would you expect? So the way to understand this is how many different masses could there possibly be? And so let's continue. We've exhausted 16 here. So let's look at 17. Let's say this first one is 17. If you do 17 and 16, what does that add to? We already got that. If we got 17 and another 17, what does that add to? We already got that. That's already going to show up on the mark.
Stop changing the answer, Ben. I always trusted, but you didn't.
17 and 18 add up to?
Just go from the lowest to the highest number.
Does this make sense so far?
Just lowest.
So that's another
Lowest.
unique one. Oxygen 18. If I do 18 with 16, what does that add up to? 18 and 16?
Oh, my bad, 34.
34, already there. That won't give a unique peak. 18 and 17, what does that add up to?
35.
So it's the only unique thing you can get here. 18 with 18 being the 2 oxygen atoms, giving 36. And the answer for that reason is 5. And that's B. So if you did get that, you can pat yourself on the back. And you didn't just guess
Patting
it.
myself in the back won't give me food back. It won't give me food.
Because 17 plus 17 is 34, and it'll give you the same like line on the graph. Do you remember the graph is? I'm just going to go back into here from last lesson. The graph is like this.
You said I could have it, right?
This. So like every
Or you just said that.
so one is how many which unique molar masses would you have? That's what the question's asking. Why did I want to go over this question? In my analysis of Cambridge exams in the past 2 years, since they've introduced this topic, I've seen when they ask a question on paper 1 about this, it's almost exactly this type of question every time. So I wanted to make sure you were aware of how to solve this type of question. And so does that mean that there's a likelihood that you'll get this on your, exam? What? I'm preparing you for the future. I'm preparing you for future you. Got to. All right, last one. I'm calling someone for this. Gamble.
Please. This one I know
This is for
Nah.
Hakeem. You don't have.
I didn't, so I was a third part.
Oh no.
Wait, miss, let me go. Let me go, miss.
We'll try one more time.
Excuse me, miss.
No. Alex.
Alex, you better give me half.
Whoa.
You got it. He got it. Woo.
You better give me half, Alex. You better give me half, Alex.
Extra
It was
donut.
almost orange.
Yes.
It was nowhere near you.
Yo, I was.
You failed me.
Give me half, Alex.
Decision. That's a churro. Okay. I think it's churro.
There's a difference over here.
All right. So let's calm it down. Answer here for anybody who needed to know. B. You've
I
got
want
the
to
B
know.
in
Alex.
1700. This area is telling us wide OH carboxylic acid most likely is B. Remember, carboxylic acid between 2,500 and 3,000. Where is the information for that? Here.
Why is it a D?
This and this. This and this. D. I'll wait till everybody's quiet. Thank you. Why not D? This is 1,700. There's nothing there. Right? There's nothing at 1,700. Definitely nothing strong. There's stuff at 1,500 there. So although the alcohol's there, the C double bond O is missing. Here, you've got the C double bond O. And this is the 2,500. This is the carboxyl at 2,500 to 3,000, right? From the carboxylic acid. So it's OH when it's part of a carboxylic acid. So definitely be here. Got it? All right. So before we can get into today's lesson, we didn't quite finish last class's lesson. So there's a couple more practice questions I wanted to do with you. You'll notice I extended the homework to give a little bit more time. And I might extend it again till tomorrow night to give time to ask questions and tutor it. Because I understand that it was kind of a long lesson. We had to cut to do the mini assessment. So there's a couple things we still needed to discuss. We stopped here. This was the last question that we did. So take out your notes from last class. We're going to cover a couple more practice questions here. And there's one more standard here we needed to cover before we get into the final lesson of the unit. So we did this question. Make sure you're identifying the last slide. This is the next question for us to do. I also want you to cross this out. We're not going to solve this one, but we'll solve other ones. This is a new to AS chemistry standard. So this question is actually from paper 4, which is why I am crossing out the one at the bottom because it wouldn't be asked exactly like this for paper 2. You'll see some in your homework that's more like what should be asked. Yes. Okay. Hold on. Wait till later.
Is there more chances to get donuts?
We'll see. So, let's go ahead and get started. Part 9. Number of carbon atoms. There is a formula you need to memorize. There's a formula for you to memorize. 100 divided by 1.1 times m plus over m plus 1. This is a formula you need to memorize. They have given you the m plus peak of 100, and they've given you the m plus 1 peak is 14.4. From this information, you've got enough to get the carbon atom. Do 100 divided by 1.1, multiply by, and it's actually the opposite. It's m plus 1 over m plus. So, you have it on the one here, sorry. It's always smaller over larger if you're unsure for your amount. 14.4 over 100. These 100s cancel. So literally all you need to do is do 14.4 divided by 1.1. Let's check what that is. I get 13.09, which you're allowed to round to 13. If it's less than 0.1, you can round it. So x equals 13 here. We're going to try this again with another question. Yeah. Yeah, you can round that to 13. If it's within 0.1, you can round it. Ready to continue? Let's take a look at this one. I wanted to, this is also from paper 4. So obviously this is not going to look exactly like questions you're going to get, but I needed to give you some practice. This comes from what used to be an A-level, but I believe you can analyze this. This right here is benzene. They've written it out in display formula for you. So at the end of every one of these lines is a carbon. They're saying the mass spectrum of this specific compound has peaks at a molar mass of 92 and a molar mass of 7. And they're asking you to identify the fragments that would make these peaks. Can you figure it out? How would you go about this? How can you get a fraction of parts of this molecule that has a molar mass of 57? What could you start doing to figure that out? Start splitting it in different places. My suggestion is to, at each carbon, like add up all the masses. So look at this C and its 3 hydrogens. What is the mass of 1 carbon and 3 hydrogens? So this is what I started doing. I wrote 15 here. And then what is the mass of 1 carbon and 2 hydrogens for the next component? 14. And this one here? And this one here? Add up all those numbers. What is 15 plus 14 plus 14 plus 14?
57.
It's 57. So the one that's responsible for 57 must be this part of the molecule. Does that kind of make sense? So you basically cut this off.
So do we write the name
No,
of that, or do we
you
just
write the formula. Cut it off, write CH3,
I think
CH2,
that's around it.
CH2, CH2, or you could condense and write 4 carbons and 9 hydrogens. What's important here is because it's a mass spectrometer, an electron's always knocked off, so you have to write it like this. Yes, Alex. Oh, sorry. It's this one. Let me delete. I would just like do an arrow, but nah. I'll write it at the bottom. So it would either be CH3, CH2, 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 plus, or the other answer you can say it as is C4H9 plus. These are acceptable answers. Yes. You could, as long as the order is the same. Like as long as it's CH2, 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 CH2. So I'll pause. We found Found the 57. Where's the 92? Out there.
Is there, can you read multiple?
Hopefully not. If there was, then there'd be multiple correct answers. But there's only 157 in this one. You'll have to write one.
Can you split the
Where else could we
cycle
split?
or no?
I would not split the cycle because benzene is always fused together. So I would say that benzene most likely. Remember, the most likely bond to break is what type of bond? I mentioned it. A single bond. Because a double bond is a second bond holding it together. So you'd have to break two bonds. For benzene, it's worse because it's alternating double bonds. So the reason they write it like this is because it's all connected together. And so it's very difficult to break the bonds in benzene. So I'm going to suggest because I've already done this, to start mapping your benzene out because the number is big. So start mapping benzene out. Nitrogen's what number? 14. And 2 hydrogens would add up to what? 16. So 16. Let's now look at benzene. This carbon is what number? 12. This carbon with this hydrogen is how much? 13. This is 13 again. This is 12. This is 13. And this is 13. Add all these numbers up. 16, 12, 13, 13, 12, 13, 13. What does that all add up to? If we were to break the bond right here, what would that be? See if it works. I've already done it, so let me tell you. Well, you gotta try it though. Does it add up? How do we write that answer? I would write it like this. Yeah. Like a terrible benzene, but it's a benzene nonetheless. It's this. Remember, you're not even going to see benzene in your examples, most likely. Yes. Can I write it what? That. Yeah, go ahead, grab us. Yes. You could. You would just have to count all of these up. Count up on this side of the bond how many carbon, hydrogens, and nitrogens you have, and you could do it that way. That's an alternative. All right. So I just wanted to show you that real quick. Yes, Vicky.
So the circle means that all the connections are double bonds?
It means that
So every bond is a double bond?
every other one.
Every other one.
Yeah, it's 3 double bonds. Okay, so just because I need to get to the other part of today's lesson, I'm going to skip the last practice question, but I have to teach you this because it's the last part of that lesson. So there's an idea of using the M+2 and M+4 peaks. And so the M peak is the molecular ion, just to review. And that gives you the molar mass. The M+1 peak, what was that again? What was the M+1 peak? It's always carbon 13. That's what the M+1 peak was. Remember, and that was always 1.1% of the amount. So the M+1 peak is always a very, very tiny amount in comparison to the molar mass peak. Now, there's this concept called the M+2 and the M+4 peaks. And you have to know very little about this, but you have to know a little. If you look back at the standards, and I'll bring them back up, it says deduce the presence of bromine and chlorine atoms. And they say only using the M+2 peak, but they have used the M+4 in question. So I'm going to bring it up. Yes? Somebody's out right now. Something you're going to have to remember, and I would just say straight up memory. Chlorine has 2 isotopes. Those isotopes are chlorine 35 and chlorine 37. And they exist in very distinct amounts. I have them here, but I'm going to write them above and below. Chlorine 35 is 25% of all the chlorine you have on Earth is chlorine 35. Out of all the chlorine you have on Earth, 75%, so it's not a very difficult number to remember, 75% is chlorine 37. This is why the average atomic mass of chlorine is 35.5 on your periodic table, because it's closer to 35 than it is to 37. Yes?
If on the graph says that Going 35 to 75, you put 20.
Oh, I must be tired because I'm saying that. Thank you. 75 and 25 is right. Because 35.5 is closer to 35 than it is to 37. And so the idea here is that most of your chlorine is chlorine 35. And a little bit of your chlorine is chlorine 37. So it turns out if we were to look at the mass spec after our M plus ion, you would have 2 above, we would call the M plus 2 peak. And because it's 25% versus 75%, what do you think the height of the peak of the M plus 2 would be? First of all, is 25% greater than or less than 75%? Less than. A third of it, right? And the peak height would be 1/3. So the M plus 2 peak would be about 1/3 the height. But you would have a peak 2 away from the molar mass. Only when you have chlorine would it be 1/3 the size. That's the idea. Now, bromine has 2 isotopes, 79 and 81. And I'm asking for you to actually memorize these percentages as well, or Cambridge really is. And the percentages are easy to remember. They are 50 and 50. So 50% and 50%. Of all of your samples of bromine, half are one and half are the other. So how would this be evident in a graph? Your molecular ion peak would be this height. And at the M plus 2 position,
So can
you
you
would
just
have
can you just
what?
say the name of, for example, O, you have to make out the depending on the O?
Hold on. What would be the size of the peak for the M plus 2 peak compared to the regular one? And so that's the big thing that Cambridge just wants you to know. They're going to give you a graph. They'll give you the molecular ion peak. And then if you see one that's 2 above, that's a smaller height, it's chlorine. And if you see one that's 2 above, that's equal height, it's bromine. That's the level of what they need you to understand for AS chemistry. So if there's 2 above that are equal height, it's bromine. This is how to identify bromine or chlorine on a graph. And if there's 2 above that's 1/3 the height, that's chlorine. That's literally the whole standard. That's what they want you to know. And you'll see that shortly. I lifted these slides from A-level because this used to be taught in A-level. So technically, this is not in the standards. M plus 4 is not in the standards for AS. They moved this concept to the AS class from the A-level class, but it's only for the M plus 2 peak if you look at the standard closely. Write this down. Make sure you have it. Yes.
Can I go?
Yes, you can. And I want to at least show you one question with it before we move on, just to make sure we have the right idea. All right, so take a look here. Identifying chlorine. This is the molecular ion peak. 2 above it, what do you see? If you see 2 above your biggest molar mass, and you see a peak that's there, and that's about 1/3 the height, what does that tell you you have? Chlorine. That's all they want you to know. And looking at bromine, the peaks are almost the same. This tells you it's bromine. 2 away from your main molar mass peak. All right, so just to take a look, and this is from paper 4, but like I said, this used to be a paper 4 standard, so that's where some of these practice questions are from. Mass spectrum of a halogen alkane containing 1 chlorine or bromine will show an additional peak. What are the isotopes of chlorine and bromine responsible for these peaks? So they're asking, what is the heavier version of chlorine? What is it? The 2 options are 35 and 37. Which one's heavier? 37. So the way you should write it is Cl with the 37 up there, where the mass or the nucleon number should be. And then for bromine, what's the heavier one? And so you would write that. Okay. So next thing they tell you, the mass spectrum of this molecule CH2BrCl has a molecular ion peak, meaning the molar mass is at 128. It also has N+2 peaks and N+4 peaks. They ask you to suggest the identity of potential molecular ions that would give rise to the N+2 peak and to the N+4 peak. So the molecular ion peak would be CH2, Br 79, and chlorine 35. The lower numbers. What would be the difference between the regular molar mass peak and the N+2? What would you be changing, Alex? Of which element specifically? And there's two correct answers here. You could either do the chlorine or you could do the bromine. So CH2, 81, 35. And is there another variant answer we could give that would also give us an N+2 peak? Very good. Cl 37. And there was a question in a paper too I saw recently that actually asked for both variants of the N+2 in this manner, where you would change one and then you would change the other between bromine and chlorine. So that's why this is a good example. What is the only way you can get an N+4 peak? I don't see why you should ask this. How would you get a peak that's 4 above this one? You would add 2 to both the bromine and the chlorine because both of those variants exist. So CH2, 81 Br, 37 chlorine. That's the only option for having a peak that's 4 higher than the normal one. It's both giving the bromine with the 81 and the chlorine with the 37. There's one other thing I need to add here because technically I haven't earned any marks. Does anybody know what I'm missing in all of these? Excellent, Diane. Because every time we give an ion, they're saying we ripped an electron off this, right? It means that our answer must be positive. So for every single one of these, just to rectify that, we would put parentheses and put a plus. Should we always do that in this process? Yes. You should always put the plus. And I know that a couple years ago when they first tested it, a student got so mad at themselves. They ran up to me, they were like, I got it, but I forgot the plus. Because it's like those little things you forget. But ion definitely means include that plus. They wanted the molecular ion, which means that's the idea of the mass spectrometer is it rips an electron off. And so you do get that plus charge there. Good? Okay, so that was the closeout from last class's lesson. We need to get to the final thing. This is actually the last lesson of the unit. If we can finish today, we do not have anything but review on Wednesday. If we don't finish today, then whatever we don't finish today, we need to finish on Wednesday. Friday is a lab. So this also is the exact lab you're going to have on Friday. It's on chemical test. So you'll notice I called it chemical test / wrap up. These first two standards we just covered. We already covered these. I just made sure to incorporate them so I knew what the plan was for today. So what do we got to do today? We've actually already done some chemical tests. I'm going to remind you of the ones we've done. We blew some sodium up. It's a chemical test, actually. To see what reacts and what the result is. We talked about bromine being decolorized with alkenes. That's a chemical test. And we have done, I think, just like one other. It's the potassium dichromate going from orange to green with alcohols. Those are the 3 we've done. We're going to learn more today. There's a reagent that can detect the presence of specifically C double bond, carbonyl compounds being aldehydes or ketones. So there's this thing, it's kind of expensive, I don't have it. It's called 2,4-DNPH. You add it to a test tube. If it gives you a certain result, you can be like, yes, it's got either an aldehyde or a ketone. Then there are other ones which we do have access to one called the Tollens reagent and another one called the Fellings reagent. That will tell you if you have an aldehyde or a ketone. And I'll explain how we do that shortly. And then finally, we've got this last one. We have this one as well. It is to determine CH3CO groups. You use iodine and you get a precipitate of triiodomethane, which is a yellow color precipitate. You'll notice that the notes today are printed in color. That means it was expensive. These notes were expensive. But the reason why is because I want you to have the colors. And you're going to see them in the lab or some of them in the lab as well, but I wanted you to have them for studying. You could literally cut it out and put it on your flashcard if you wanted to. But I did want to print out the colors for you so you had it for your chemical test study. All right, here we go. So moving into what we got to do. Testing for aldehydes and ketones. Notice I bolded and underlined. This is, in the grand scheme of things, a section that there's a lot of test questions on a typical Cambridge exam about. Usually there's a lot on paper 1, that's the multiple choice, and sometimes there's a whole section on paper 2 on chemical tests. So make sure you're paying careful attention to what you need to know and how you need to know it. First thing is this reagent called 2,4-DNPH. You do not need to know its whole name, which is 2,4-dinitrophenylhydrazine. You do not need to know that. But on inspection, you need to recognize the 2 and the 4, and then just DNPH looking stuff. Like, they could say the name and be like, okay, the 2, the 4, the DNPH. They could write it out. And the idea is that if you have a sample of an unknown, and you add 2,4-DNPH to a test tube with it, it's going to give you an orange, it looks like an orange juicy, like, have you ever seen orange juice with thick pulp? Like an orange juicy precipitate, thick, not see-through. And so if there's an aldehyde or a ketone, you'll get an orange precipitate. The thing is, how will you specify if it's an aldehyde or a ketone? They actually react differently. Some compounds have aldehydes, some compounds have ketones. And so, I don't have a question already. Literally, the answer has to be, let's check it out. Which reagent, and it's not what you think it is, which reagent gives the same results with propanol and propan-2-ol? So first of all, we haven't learned tolerance yet. How can that be the answer?
I think it's A, and if it can't be A, it has to be the other thing that you mentioned at the beginning.
No.
Logic.
Okay, careful attention to how we do this. What is propanol? CH3, CH2, COH. That's an aldehyde, right? That's what's important here. What is propan-2-ol? Really, the real question is, which of these reagents react with both? Because this is K2Cr2O7, which oxidizes alcohol and oxidizes aldehyde, right? The aldehyde would turn into a carboxylic acid. Just to give you the result. This is with K2Cr2O7. And what would K2Cr2O7 do to this? What would it turn into? Go ahead. Question, bathroom?
So they oxidize alcohol and oxidize
And it oxidizes aldehyde. So it turns an aldehyde into a carboxylic acid, right? What does it turn this alcohol into? It turns it into a ketone. And so the answer is B. What's the color change, though? We're going to see it on Friday, but what's the color change? It's actually from orange,
Correct.
because potassium dichromate is orange, and it turns to green. It's orange to green. That's the potassium dichromate is orange. Like I said, you'll see it on Friday. But you may as well write it down. Okay. We're going to continue shortly. Okay. How do we specify between aldehydes and ketones? You want me to go back? One way, which is very expensive and very boring, is to determine the melting point. What do I mean by that? When I was studying organic chemistry, when we made a compound of a specific functional group, we would have to sit and watch it melt. And sometimes it would take 10 minutes, sometimes it would take 70 minutes, sometimes it would take an hour and a half, and if you missed it, you missed it, and you had to redo it. Boring. And expensive, because the melting point apparatus were not cheap. And so you could refer to the handbook of chemistry and physics and figure out like the melting point of your specific compound, and then find the melting point. However, if you want an easy way to know the difference between an aldehyde and a ketone, there's a simple chemical test you can do. There's two of them you can do. One of them we'll be doing on Friday. It's important to note that these chemical tests do not work for carboxylic acid, do not work for carboxylic acids, and do not work for esters. They only work for carbonyl functional groups, not carboxyl functional groups. And so they will only react with either, we'll figure out what the difference is between an aldehyde and a ketone. The first one we're going to use, and this is, it could be, we'll see if you do it right. This might be your favorite experiment of the year. The first one is called Tollens reagents. If you have an aldehyde, and you add Tollens reagent, which you're going to create and make on Friday, I'm going to give you the instructions for that. It is an aqueous solution of silver nitrate. You remember about silver? Anything about silver nitrate? It is something that will stain you if you get it on you. Like it'll stain you like a dark brown. Because it actually reacts with your skin. The only way to get it off is to like scrub and scrub and scrub, but you're actually scrubbing off the top layer of your skin. So it'll come off in a couple of weeks. Or maybe faster if you scrub really hard. But you would be wearing gloves, right? And be using safe lab protocol on Friday. So silver nitrate in an excess of ammonia is going to be something that, if you have an aldehyde, will produce a silver mirror. What happens is the silver nitrate will go to silver solid. And you will form a silver mirror. And it'll be made out of silver on your test tube. If you do it right, yes. A mirror. You'll be able to look at your face through it. Like it'll be reflective, like pure silver, on the inside rim of your test tube. Okay. So this is going to be a lab you're going to be actually doing on Friday. That's why I said we got to do the machine assessment at the beginning of the class so that you have the full rest of the class to work through what you need to, because it does take some time to do, but if you get a good result, it is beautiful. Yes.
If it stains your skin, does it stain your clothes?
If you're wearing black, you're fine. If you're wearing white,
That's not fun.
maybe don't wear white on Friday, is my suggestion. All right. So, if silver and silver nitrate is being changed from a +1 charge to a 0, let me get your attention. Is silver being oxidized or reduced in this process? It's going from +1 to 0. Oh, it's being reduced. So what's happening to your aldehyde? Is your aldehyde being oxidized or reduced?
Oxidized?
So aldehyde is being oxidized by Talon's reagent. All right, this is important because if you understand this, you'll understand the difference. Aldehydes can be oxidized, can't they?
Yes.
Can ketones?
No.
So would a ketone make the beautiful silver mirror?
No.
Do nothing.
So it would do nothing, because forever ketone. So Talon's reagent will turn beautiful silver when reacted with an aldehyde, because it will oxidize the aldehyde as it is being reduced, because it's a redox reaction. But with a ketone, you will be bored and sad. It will do nothing. What? So I mean, I'll give you an aldehyde to do, obviously, on Friday, because like, I want you to have something
Just the
nice to
ultimate
look at.
disappointment. You put it in there, nothing.
But if you choose to react with the ketone instead, I am not responsible for your boredom and sadness. That would be an example of getting the method wrong and then being sad as a result. All right. Does that make sense to you though, like that whole process of how that occurred? All right. So Talon turns beautiful silver with aldehyde, does nothing with ketone. The other one you've got to know is stellene. Stellene is actually a mixture of copper sulfate. I'm going to write this down because you may or may not be familiar with copper sulfate. Sometimes I've used it, especially I use it more in the pre-ACE class for experiments. We're going to see it next month more. It is a beautiful blue, deep blue color. Copper sulfate is always a nice deep blue color. If you have an aldehyde, the copper reacts and you get orange. What do you think is like an orangey color? That's copper, right?
Yep.
So you've got copper 2 plus going to copper. Copper being reduced and aldehyde being oxidized. So once again, what would happen with a ketone? Nothing again.
So we work with any sulfur. Ketones, thanks ketone?
Ketone, say ketone. So if I had a ketone and I threw this solution in a ketone, it would stay dark blue. And you'd be like, okay, boring. So what is the strategy then to figure out aldehydes and ketones? The first,
color or not?
if it changes color or not. First thing that they'll tell you is add 2,4-DNPH. This will tell you if it turns orange that it is either an aldehyde or a ketone. Then to verify which one you've got, you could choose Fellings or you could choose Tollens. We will choose Tollens because it's prettier on Friday. But if you get a silver mirror with Tollens, aldehyde. No silver mirror, ketone. If you get orange with Fellings, that means aldehyde, you gotta change. And if it stays blue, you have ketone. That's the idea. All right, so let's take a look at a question. I love these bullet Cambridge questions. Yes.
For the paper,
You mean paper 3?
Yeah. Does it tell you what type of thing or just
We'll talk more about paper 3 after we finish the content. However, you will always have qualitative analysis. What do I mean? Qualitative analysis is figuring out what you have. So could chemical tests show up on a paper 3? Yes. I have had a lab where they had to make a silver mirror before, as part of their lab exam. And if you know the content, you know that if it makes a silver mirror, you have an aldehyde. You could get those questions, correct. And so part of the lab that is guaranteed is that you'll have qualitative analysis, which is the last ones we're going to do, starting on Friday and then when we get to the final part of the class. And then you have either 1 or 2 math type labs. And there's a distinct list you could choose from. It could be, and I mean, you don't get the choice, but there's only a distinct type of labs they can give. It could be titration, it could be kinetics, it could be crucible, it could be enthalpy. We've done all those types, by the way. And so when we get to April and May, we'll be practicing all of our types again, because there's only a certain amount of different types of labs that they can give. So you'd be prepared for whichever types they give. Does that answer your question? All right.
No one able to go. Yes, correct.
Yes, it is. All right. Which of these compounds can be oxidized for the first part by K2Cr2O7. I heard the final answer. Can all of them be oxidized?
No, I don't think. Yeah, why can't?
Yeah,
Why
why
why is
about-
it?
Why is it ketone?
No, why is it secondary alcohol?
Yeah.
I think they can all be oxidized.
Oh yeah, they can all be.
This is primary alcohol, aldehyde, secondary alcohol, aldehyde. They can all be oxidized. So this is not the part that matters. Which one gives a positive result to tolerance? This and this.
Those are aldehydes.
See.
Wouldn't the primary alcohol turn into an aldehyde?
No, because it turns straight to a carboxylic acid.
Oh.
And if they were just to add tolerance to this, they're not adding K2Cr2O7 and then adding tolerance. They're adding K2Cr2O7 and then to a separate test tube, they're adding tolerance
Oh.
to that same alcohol. Does that make sense?
Yeah.
All right, let's try another one. Which one will give similar results for butanone and butanal? So which one would give you the same results for an aldehyde and a ketone? And there it is. Just look for that 2 and that 4, and then some kind of DNPH looking thing. Yeah, it's ketone. All right. Aldehydes and ketones are carbonyls. Which of them will react with NADH4 and react with Bellings?
Aldehydes.
Only aldehydes. Look at how many questions. Look at how fast you can do them if you know your content. These are like, no, I'm not going to say 3 points, but in comparison to other questions that are worth the same 1 mark that take you 15 minutes to solve 1 math question, do you think you should memorize chemical tests?
Yeah.
I highly advise it if you're trying to pass the exam. This is a section that you can do quite well in with just a few pieces of information. All right, so review charts. These are some experiments to identify aldehydes and ketones. Some of these you're going to see on Friday with our lab. Actually, most of these we're going to see. The first one, KMNO4. The last time you've seen KMNO4 is in a titration, I believe. I may not have actually done it because I think it starts with your group. So KMNO4, oh, yeah, don't wear white on Friday. This also stains. It stains brown. It doesn't look nice. It looks like, you might have had an accident. Not great. I'm being honest with you. Like, you don't want to wear white with these. So, KMNO4 itself is purple. And like a dark purple. If it is oxidized, or if it is oxidizing an aldehyde, it's going to turn light pink or colorless. Light pink is the end point. And colorless is actually too far if we were talking about a titration. But that's KMNO4. It starts purple, it either ends light pink or colorless. It will only give a positive result with an aldehyde because can KMNO4 act on a ketone? Forever ketone. Yes.
So why is there two different chains?
Are you talking about for light pink or colorless? Light pink is the end point, meaning the equivalence point for the titration. If you had went too far, you would get colorless. Like if you kept pouring it, it would be colorless. Acidic, K2Cr2O7. Aldehyde, orange turns to green. You think this is good stuff to maybe put on flashcards? Ketone does nothing. Orange stays orange. Tollens, you get a silver mirror, which means you get a actual silver on your test tube. Ketone does nothing. You see there's a kind of a pattern here. Bellings, you get a brick red color with ketone, no reaction. So I'll give you some time if you want to write down flashcards for these different tests that some of you are writing. I also mentioned if you wanted to cut out the colored test tube from the lesson and put them with your chemical test, you can feel free to do that, but I am not reprinting the lesson, so that's up to you. Hey, that costs like probably $10 or $15 just to print out today's lesson. Now for the class, but still, that's like $10 or $15. I just see money flying away. I gotta get a different printer. This one's too expensive. I thought laser printers were cheaper. We've spent about $1,000 I think this year so far.
You should like write the chemicals and
You should
the
write
reactions of each.
what it does with aldehyde. Like positive test, and then ketone, no reaction. I'm giving you some time if you're writing flashcards, and then we'll continue. And remember, you will get to memorize this some with actually doing the lab. It'll hopefully help you to memorize some of these changes and lack of changes. All right, I'm holding for a little while longer. Anyone you still need to do, you could just make a mark for yourself to finish it later. About 30 more seconds. Yes. Yes, you may. Go ahead, grab a pen. All right, moving forward. So make a mark wherever you were at. We're going to continue. We still have some things to do. Check a 5. Melting points are given. I told you if you really wanted to know exactly what you have, you would throw it in a melting point machine and you would watch the sample melt, turn from solid to liquid. It could take a long time. It is very boring. It was like my least favorite thing about organic chemistry labs. But the question at the bottom says, what would be observed when each of the carbonyl compounds is mixed with 2,4-DNPH? Go ahead, Alex. No, but they're asking, what would you see for all of these with 2,4-DNPH? Go ahead. Yes. All aldehydes and ketones will turn orange. Will form orange. Precipitate. Cambridge allows you to write what for precipitate? Do you remember? I'm sure you can write PPT. If you don't want to write all those letters, like I don't, you are allowed to write PPT. They write it in their mark scheme. Orange PPT. But it is like you get a solid orange out of it in every case. So that was that checkup. All aldehydes and ketones will form an orange solid PPT. On your next slide, you're going to see that it's blank. I did do some extra work with your specific class last week on this. What are the chemical tests for carboxylic acids? And so I want to bring it back a notch because there are other chemical tests that I told you we've done already before today's lesson. One of them was carboxylic acid. What could we see with carboxylic acid? So let's go back to it. Let's say we have CH3, COOH. What could we react with this to give a positive result that could be observed? Something would be observed. Nope, not HCl. Anybody remember? H2 is the product. What do we react it with? You could do a carbonate. Beautiful. Na2CO3. Reagents. What's the result from this?
Water and the other one.
CH3COO, not.
Water,
And then CO2. What is the observation of this chemical test? So the positive test would be bubbling or fizzing, or the fancy Cambridge word is
Effervescence.
effervescence. What? You don't like that word? Effervescence.
No.
Ever? It's too much? It's too extra?
Yes.
All right, just write bubbling.
Or 15.
Fizzing is good. I think fizzing is a good medium, like meet 'em halfway. Fizzing has that
Mix of regular.
of regular and like spruce it up a little bit.
Effervescence is just so.
It's so much. It's too much.
And then metal, like sodium.
I wouldn't even, if I tried to spell that on the test, it's going to be so wrong.
Wouldn't be saying that.
So fizzing. Just go with fizzing. All right. The other option. Add sodium. Right? Pure metal. The best results with sodium. But you could do another one. But remember the one with sodium. You can do any group of metal technically, right? It will give the same result or similar result. Because elements in the same group act similar. Una. And what's the other product here? Nope. Not water. H2 gas. What is the observation? Bubbling, fizzing, effervescence. You want to write fizzing this time? They're the same thing. Fizzing. What else would be another thing you could do with like what's the observation for H2 gas specifically? It actually is explosive, right? Yeah, it explodes, right? That's what we got. It's explosive.
Yeah.
But fizzing at minimum. If you want to do less. Those are your two chemical tests for carboxylic acids. They both give gas, technically. They both give fizzing. So if you add Na to something and it doesn't do that, it's not a carboxylic acid, right? There's one more chemical test. And it is the final standard, I think. It's the final standard. And yeah, we're on the final standard of the unit 6, right? This is the final standard of unit 6. And this is the final chemical test you need to be aware of. I do have this reagent, I believe, so I will be able to show it to you on Friday. And this is called the triiodo. Yes, it's called the triiodo methane reaction. And last night when I was working on putting this together or organizing it, I put a picture again of the results so you can see what the positive result actually looks like. So this precipitate, it is like a light yellow. When you see it, it's actually light yellow. But they just say that this is yellow. So if you've got a specific group on your molecule, that specific group is either a methyl ketone, so you may want to put a box around that, or a methyl group next to an alcohol. So we call this a methyl ketone. And this is a methyl alcohol. If you take iodine, a solution of iodine, like pure elemental iodine, and you mix it with sodium hydroxide, and yes, that will be aqueous. What happens is the following. This carbon gets knocked off. The carbon gets knocked off. And you get this product. The carbon gets knocked off. It goes with the iodine. There is no mechanism. I wish I knew the mechanism for this. I don't. You don't need to memorize the mechanism for it. But this is called triiodo methane. Does that make sense to you? Like that name? Mono, di, tri. Tetra. There's 3. Like if there were two, it would be di-iodine. 3 means tri-iodine. Why is it called methane? 1 carbon. So what happens in this reaction specifically is the carbon on the side gets knocked off. It gets replaced with an oxygen. That oxygen is coming from the sodium hydroxide. And you're left with una, and you're left with this precipitate. So the positive result, and most of the time Cambridge just asks for the positive result here, is that you get a yellow precipitate. You do need to memorize the name of this product, and that its formula is CHI3. This is called the triiodomethane reaction. This is the yellow precipitate, is this specific compound. So if you see a test tube that looks like that, with that yellow there, that falls to the bottom, it looks just like this. That means that you have the triiodomethane as your product. This can only happen with methyl ketone and methyl alcohols, meaning you've got a ketone with 1 carbon next to it, or an alcohol with 1 carbon next to it. That's the final type of reaction. We have a couple questions to close off this today, and then you do have a mini assessment. Yes. Grab it. Yeah. Oh, you got 3. I think you are. Well, then you can start this one.
Yeah, but that means I can't top this one.
How would I know if I'm in the top 5?
Did I write it on your?
No,
Oh, I can tell you after next one.
How many top 5 were there?
I've heard
Is
like
it
varying
one for
things on this
everything?
because I was told by some people you don't have to sign this. But he just said you have to sign it. Oh, okay. Yes. Yes, because I'm your teacher. So yes. All right, we didn't sign last year, that's why I'm confused. But it's okay. All right, let's do a couple questions before we close out. I will sign your stuff. Let's do after we finish a couple questions. All right, so multiple choice first. 2 suggestions are made about this. They tell you this thing can be oxidized by dichromate. Yes or no?
No.
Why not?
It's ketones.
It's no. No oxidation. Forever ketone. Don't do it.
So,
All right. What about statement 2? Be careful here.
the
Steven?
C or D?
Statement 2 says 1 mole of this compound gives 1 mole of CHI3. So look at it closely. Is this a ketone?
There's 2 ketones, so they need to be ketones.
Isn't this a thing that can get knocked off as CHI3? All right, annotate that. On the other side, is there another ketone?
Yes.
Yes.
Does it have another CHI3 next to it?
Yes.
So can that get kicked off?
Yes.
So 1 mole of triiodomethane is not true. It gives 2 moles.
So,
So the answer is? All right, that's the first question. Now let's take a look at a paper 2. Paper 2. This is paper 1. Paper 2. Complete the table to show what you observed. When glycolic acid is reacted with each of these reactants separately. Let's take a look. If I took Na2CO3 and I reacted it with this, would I get an observation? We just looked at it.
what?
Glycolic acid plus Na2CO3, will that give me a reaction, yes or no?
Yes.
Yes. What's the observation? That's the point. There's the point. It's in saying that. Does a reaction happen? Well, obviously, if there's fizzing, the answer is yes. What is the functional group identified?
Carboxylic acid.
They accept either you to write COOH or say words. Carboxylic acid. I'm just saying the different ways you can answer that are both correct. Good with that one so far? Second one. 2,4-DNPH. What's the observation?
Nothing.
No.
You're allowed to say nothing happens. You're allowed to say no change.
Can I say none?
You can say no observations. Yes, that is good. Does a reaction occur? Functional group, they just said Na, like not applicable. It's not identifying a functional group on there because you don't have aldehyde and you don't have ketone. Because remember, this is aldehyde and ketone only. And then finally, Cr2O7 2 minus. Does that react with anything here?
No.
Sure about that?
Oh, the
This is a primary alcohol, isn't it?
yeah, I didn't see that.
Oh yeah. That gets oxalic acid.
So the observation is, and they said orange turns green. It's the way that they wanted you to remember it. Like it starts orange and it turns green. Well, if it turns green, does a reaction occur? Is
Yes.
color change like a chemical change? Yes. What's the functional group it's actually identifying here?
Aldehyde.
Not an aldehyde.
Alcohol.
It's an alcohol, right? So they only said you needed to say alcohol or OH. You could say it like that. And that was fine. 4 marks here. That's pretty substantial.
Which would be more specifically right? Like, would it be better if I always wrote alcohol, or better if I always wrote OH?
OH. It's a good question. All right, last slide. Next slide is the last slide. The summary I'm going to do next class when we do our review. Student carries out several tests. Complete the table for observations of P, Q, and R. If no reaction occurs, write no reaction. 3 marks, 1 for each line. Does sodium react with this? Yes or no?
No.
Does sodium react with alcohol? It does. Is there alcohol here?
Yeah.
What does it do? Bubbles. Fizzing. Does sodium react with Q? It's a ketone.
No.
Does sodium react with R?
Yes.
Is that an alcohol?
Yeah.
Is that an alcohol? They're messing with you. If you said this was an alcohol, what's the problem with that?
Oh, carbon only has 3 bonds. Or 2 bonds.
Right? So, no. What is it? It's cho, right backwards. This is an aldehyde.
Oh.
It has to be an aldehyde, doesn't it?
Oh yeah.
It's cho, right backwards. You see it? That was mean. Keep it with me here. Do you agree though? But it can't be alcohol. If you work it out, it don't work out.
Oh, that's no reaction.
So no reaction. All right, 2,4-DNPH. Does it react with this?
No.
Yeah.
It's a ketone. So the reaction is orange, PPT. 2,4-DNPH, always orange PPT.
Oh yeah.
R, it has, we just discussed that CHO is an aldehyde. Does that react with 2,4-DNPH? Same thing. It always does the same thing. Orange PP. P. All right. Final. Does Q react? Does Q get oxidized? It's a ketone.
Yes.
You cannot put an OH there. It will break the oxide bond, right? So no reaction. But will this react with an aldehyde?
Yes.
And what's the color change?
Orange degree.
Orange to green. And that's it. All right. So practice with this? Yes, you're going to have a lab on Friday. We're going to also review on Wednesday. Your final mini assessment next week is going to be solely on chemical tests. So today's mini assessment and Wednesday's mini assessments are on reactions. Friday is just on mechanisms. And next week, Tuesday, is just on chemical tests, just to make it clear. All right, you have till 2:05 to either take a brain break or review real quick. Your next mini assessment is taking place at 2:05. 2:05. Ved, I can tell you if you come up here, you are currently in, because it won in 9th right now.
Oh, okay.
Mini 5 hurt you.
Huh?
The last one messed your score up. You're actually not that far though.
Okay.
So if you can do well, you could still make top 5.
Study.
If you
Study.
need to sign your paper, I can do that while I'm waiting.
Where's mini assessment 5? Study. Telling the information, and I'll just
Reactions, right?
I
Reactions.
expected a 50 from you.
I expected more than 50 from you.
That was my
40.
That was
You got
the
40.
first one I sold. That was the second one. That was the second one. It's Mars. That was the second one.
It was definitely.
That was my first one I sold.
Sure.
That was the first one. All these got in 7
Yes.
And then,
Yeah, but I mean,
oh, right, I forgot.
Explain.
the break, right? No.
Only break.
Oh wait, it's away from both sides.
I don't even know what I was doing.
What the fuck?
It doesn't make sense.
What the fuck did you do?
So, focus.
Let it look completely opposite, so that the other
K2, CO2,
It's a primary alcohol, right?
Yeah. This would be. That's which side?
Working.
For the phone.
Wait, hold on.
Play back.
It does get away. Just wipe it.
I think.
You think?
Pure? Like Stefan, I don't know. This would be correct, right?
It doesn't get
Wrong.
what?
Oh, I just have it on here. That's it. That's all I did. Oh, there you go. Alex, listen. Okay.
Oh, it's there? Anyone can do it.
No. Right? So look, let me explain it to you. This is the primary alcohol, right? So primary alcohol, you take away this H, make a double bond O, and then you take away this H, take away these two H's, make this a double bond O, and then add O to
You
this.
would change all those names. Not have their real name. Also, half of them are like misspelled. Like very badly.
What if? Is it crazy?
If the condition, if it doesn't say H plus or heat, then it's no reaction, because that's a condition. Also, if this was a ketone, for example, if this was like this,
No.
the discrete formula was like this.
All right, 3 minutes till I'm asking you to put your stuff away. 3 minutes.
like this, with double bond O in the middle, it
Why that guy?
would be this, it would be no.
Oh yeah.
Always make it.
Oh my
Ketones
god.
always make it.
Ketones always take.
If the reacting was
How do
this,
you
then